Okay, back again. This is the second OSPF video. The first one went through most of the commands, and we'll really just review them in this one. The change of this one has not been the IP addresses around the outside, it's been this network on the inside. I've got rid of my serial connections, so it's not a point-to-point system anymore. It's a broadcast multi-access, a BMA, and that's just an Ethernet switch. It's a 2960, and they're all part of the same network. So the network number here now is 10.0.0/24. Got rid of the 12 network, the 11 network, and the 10/30 networks. We now have one connection into this network, and we'll go through and use OSPF and configure it. So all the commands we're going to use are actually the same, but the outcome will be slightly different because the way this system works is different as far as OSPF is concerned. So let's go through and configure stuff. So we'll put in our commands, OSPF and 10. Now in this case we really do need our router IDs. That's going to be used to negotiate between these systems. We're setting up a thing called designated routers and backup designated routers, so DRs and BDRs, and it does it automatically. It's just the way that OSPF works. If you do get into a non-broadcast multi-access, which is a frame relay style of network, OSPF in this form won't work. You have to actually change it. But anyway, let's just pop it in and chuck in our commands, And area 0, everything going area 0 again, and then our network for the 10 network as well. Whoops. So that's it. We won't put passive down there, you know how to do that hopefully. So that's good to go for router 1. We'll do router 3 and then have a look at what's happening. Router OSPF 10, we're using the same process number this time, so router ID and networks 172.20.0.0 wildcard array area 0. Not all correct, I put an extra 0 in there, got all carried away. Now we should form an adjacency there, which is done. And let's just have a brief look at what's actually happening. So if I show IP route, we don't get it's all done. That should be broadcasting out. Yeah, finally. Okay, it took a little bit longer. Okay, real routers happen a wee bit quicker than that, sorry about that. Okay, so what we did, we'd formed an adjacency back here, which is the hello packet. It says, hello, I'm on area 0. Are you on area 0 out there? And this guy says, yes, I am. And you go, oh, we're friends. Good. So we've formed neighbors. Then they've gone through and negotiated, and that's the delay. Actually typed too quick. Who would have thought? So the delay is getting a negotiation happening between the two. So let's have a look at this router here. So if you show IP OSPF neighbors, or neighbor, we've got a difference to what we did when we had point-to-point. Our neighbor is on 10.0.0.1. Our neighbor ID is 11111. But now we've got the state, and the state is that we've negotiated as to which of these routers has the lowest router ID. And that router has become the designated router. Now because we only have one other router in this network at the moment, because the router 2 at the top is not participating. It will in a minute, but at the moment there's only 2. This one is the backup designated router. And the process that we're actually going through is this router will send, well, actually the process, form neighbor adjacencies, then negotiate who's the designated router and who's the backup designated router. In this case, router 1's designated. Then all the other routers that are in the system will send their link state updates, which is now type 2's LSAs, to the designated router. That designated router will collate all of them and then send them back out to every individual router across the network. And why do we do this? Because in this case, there's only 3 routers. There's not going to be a lot of network traffic, really. But you could have a virtual switch, which is really just software running, with all these routers sitting on the outside of this cloudy bit. And there could be hundreds, if not more, routers all running OSPF and all sharing information across this network. And when you have that, that's a lot of traffic. If there's any subtle change to the whole network, poof, you've got a lot of traffic again. So we set up one router, and it does it automatically as the designated router, and that's the one that holds this master record, if you like. And we have a backup as well, so it has a backup copy of the master record. And because of OSPF's function, that the shortest path first algorithm, and being a link state protocol, every router has the same database, and every router makes its own decision through the algorithm of the best path to the other networks across the network. So we can do that. We send all the link states up to, in this case, router 1, the designated router, and it collates them all, and once it has it, it sends it out individually to all its neighbors. And it all works quite happily. So let's just have a quick look on router 1, and if we show IP OSPF neighbors, we can see that where our state is full, that means we fully negotiated and we are the designated router. If we show IP OSPF database, then we've got our network link states, and that's link state types 2. Interesting, we got link ID there. Should be a 3. No, actually it's not. It's a link.